Hey everyone, today we'll be factoring quadratics with a leading coefficient of 1. Now, as I've written here, the goal of factoring is to turn a quadratic into a product of binomials. So it's going to look something like x plus a times x plus b, where a and b are some numbers. Now to do this, we're going to first multiply out this generic product, and I like to do that in a table. So here we'll have x plus a times x plus b. We're going to multiply these two by multiplying each column by each row. So x times x, or x squared. We've got a times x, or ax. We have b times x, or bx. And we have a times b, or ab. Now, you might notice that this is actually functionally equivalent to the FOIL method that you might be used to, in that it multiplies every pair of terms in the binomials. But I think doing it this way gives you a little bit of a clearer picture of what's going on. Anyway, let's collect our terms. So we've got x squared plus ax plus bx. And here I'm using different colors to represent different degrees, plus ab. And remember, we want this to be equal to x squared plus 7x plus 12. Now we see that x squared is already equal to x squared, so that's already satisfied. There's no need to worry about it. But what we do need is a plus b equals 7, and ab equals 12. We need to find two numbers that simultaneously satisfy both of these. Now, it's just trial and error at this point, and I like to make that a little bit more organized by, systematically going through them in a table. So I will draw a plus b here, a and b here, and we'll start sort of at the extreme end, where a is 1 and b is 12, because those are the most natural things that multiply to 12. So we've got a as 1, b is 12, and in that case a plus b is 13, which is not equal to 7. All right, what else? We can slowly move a up. We'll do a is 2 and b is 6. In that case, a plus b is 8, which is not equal to 7. Move up again. We got a is 3, b is 4. And that gives us a plus b is 7, which is equal to 7. So 3 and 4 are the numbers we want. Now that means that our original quadratic is going to equal to x plus a, which is 3, times x plus b, which is 4. And we're done. All right, let's do another example. Here we've got the quadratic x squared plus 9x plus 20. And I've got everything set up here with the table. Just like last time, we want a times b to equal the constant term, which in this case is 20. And we want a plus b to equal 9, or the coefficient of x. Okay, so we'll start from the beginning again. A is 1 and b is 20. We have a plus b is 21, which is not equal to 9, unfortunately. Okay, moving a up, we've got a is 2 as the next factor of 20, and that corresponds to b is 10, so we'll have a plus b is 12, which is unfortunately still not equal to 9. Moving a up again, 3 is not a factor, so we'll try 4, which gives us b is 5, and that gives us a plus b equals to 9, which is exactly what we want. And that means our quadratic was equal to x plus a, which is 4, times x plus b, which is 5, and that's our factoring. All right, let's do a third example. We'll have x squared minus 12x plus 32. And in this case, our constant term is 32, so a times b should be 32. And the coefficient of x is minus 12, so a plus b should be minus 12. Okay, let's open up like before. We'll do a is 1 and b is 32, and that gives us a plus b is 33, which is not equal to minus 12. But not only is it not equal to minus 12, it's sort of wrong in an even bigger sense, in that it's not even the right sign, right? Minus 12 is a negative number, and we should be looking for a and b that will sum to a negative number. But if we keep on trying positive numbers for a and b, we're never going to get that, right? Two positive numbers will never add to a negative number. So at this point, we need to remember that two negative numbers can also multiply to positive 32. So we'll go -1 for a, and that corresponds to -32 for b, and that gives us a plus b is -33, which is still wrong, but at least it's the correct sign. All right, moving on with the trend, we can try a is 2 because that's a factor of 32, and b is -16, which corresponds to that a, and that gives us -18 for a and b, or a plus b, which is still not -12, but it's getting closer. Moving on, 3 is not a factor, so we'll try -4. That corresponds to b equals to -8, and that gives us a plus b is -12, which lines up perfectly. So that means if we plug things in again, we get our quadratic is equal to x plus -4 times x plus -8, which, if you would like to simplify that, is equal to x minus 4 times x minus 8. All right, let's do one last example involving negative numbers. Here I've got the quadratic x squared plus x minus 12. And this means, since our constant term is -12, that a times b should be -12. And since the coefficient of x is 1, we have a plus b is equal to 1. Now, because a times b is a negative number, we know that one of a should be negative, or one of a and b should be negative, and one of them should be positive, because two negatives, as we saw, multiply to a positive, and two positives also multiply to a positive. So let's try a is -1 and b is 12. And that gives us a plus b is 11, which is not equal to 1, but at least it's the correct sign. So we know we're somewhat on the right track. Okay, let's try a is -2 and b is 6. That gives us a plus b is 4, which is not 1, but getting closer. Okay, next up we can try a is -3, which corresponds to b equals 4. And that gives us a plus b is +1, which is exactly what we want. And that means our original quadratic factors out as x plus -3 times x plus 4, which, if you simplify, is equal to x minus 3 times x plus 4. And there you have it. That is factoring quadratics with a leading coefficient of 1. Thank you all for watching.